What is good, everyone, and welcome back. Today we are building Interview Ninja from scratch. Interview Ninja is a full-stack AI-powered coding interview platform. Candidates sign in, browse live interview sessions, write code in a VS Code style editor right in the browser, and get instant AI feedback on their submission. Scores, strengths, weaknesses, time and space complexity, all generated by Claude from Anthropic in real time. On the recruiter side, you create sessions, add coding questions with difficulty levels and expected concepts, and watch candidate submissions come in live. The entire backend is powered by InsForge. Auth, database, storage, all in one platform. This is a long build, so let us not waste any time. Let us get into it. Let me walk you through the architecture diagram so you have a clear mental model before we write a single line of code. Looking at the diagram, everything starts on the left with the front-end layer. Inside it, you have three key pieces: the AuthGuard, the candidate dashboard, and the recruiter dashboard. The AuthGuard sits at the entry point of every protected route. When a user hits a candidate or recruiter page, the guard runs first. It checks the session, fetches the user profile from the database, reads the role field, and routes accordingly. If the role is candidate, it renders the candidate dashboard. If the role is recruiter, it renders the recruiter dashboard. If there is no valid session at all, it sends the user back to the login page. Also, inside the front-end layer, you can see the sidebar and the Monaco editor. The sidebar is role-aware. It shows candidate navigation to candidates and recruiter navigation to recruiters. The Monaco editor lives inside the interview session and is where candidates actually write their code. Moving down to the auth layer at the bottom left. The flow starts with Google OAuth. The user clicks continue with Google. Google handles the authentication, and the OAuth redirect lands at the auth callback page. The callback verifies the session through InsForge auth and issues a session token back to the front end. That session token is what the AuthGuard uses on every subsequent page load. Now look at the middle of the diagram. The API layer sits between the front end and everything else. The Next.js app router acts as the route handler, directing traffic to the correct endpoint. The most important endpoint is post/API/evaluate. This is the route that runs every time a candidate submits their code. Following the arrows to the right from the evaluate route, you can see it connects to the AI layer at the top. The evaluation prompt goes to Anthropic Claude. Claude processes the code against the question context and returns a score and feedback JSON. If Claude hits a rate limit or is overloaded, the arrow shows a fallback path to the fallback heuristics function. This ensures the candidate always gets a response, even when the AI service is having issues. The evaluate route also connects downward to the InsForge platform layer. Two things happen here. First, the raw code file gets uploaded to InsForge storage as a blob. Second, the score and feedback get written to the database via the REST API. Inside the InsForge platform, you can see the full data path. The REST API queries and mutates the Postgres database. The Postgres database enforces every query through row-level security before any data is returned. Row-level security filters by user ID, by session access, by recruiter ID, and by candidate ID depending on which table is being accessed. No user can ever see data that does not belong to them. The database enforces this regardless of what the API receives. On the far right is the database tables layer. 4 tables: candidate attempts table, users table, interview sessions table, and questions table. The arrows show how they relate to each other. Candidate attempts are filtered by candidate ID, users are filtered by user ID, interview sessions are filtered by recruiter ID, questions are filtered by session access, and questions belong to sessions. shown by the add questions per session arrow connecting those two tables. Looking at the arrows coming back from the database to the front end, you can see 3 return paths. Available sessions list goes back to the candidate dashboard, so candidates can see what sessions exist. View candidate results goes back to the recruiter dashboard, so recruiters can see how candidates performed. And fetch history and stats goes back to the candidate dashboard at the top to populate the submission history and KPI numbers. The final connection worth noting is the @InsForge/SDK label on the arrows connecting the candidate dashboard and the recruiter dashboard directly to the InsForge platform. Both portals talk to InsForge using the same SDK client initialized in lib/insforge.ts. One client instance handles authentication, database queries, and storage for the entire front end. That is the full picture. Auth flows in from the left through Google OAuth and InsForge. Code submissions flow up through the API layer to Claude and back down as structured feedback. Data persists in PostgreSQL, with row-level security enforcing every access rule. And the SDK ties the front end directly to the backend for everything outside of AI evaluation. Now let us build it. Real quick before we dive in, we are deploying this on Hostinger, and I want to show you why I picked them for this project specifically. Interview Ninja is not a simple static site. It is making authenticated database calls on every page load and hitting the Anthropic API every time a candidate submits code. You need a host that can actually handle that without going down or slowing things up. Hostinger has been solid for me on projects like this. Let me show you exactly how the deployment works so you can follow along later. Go to hostinger.com and sign in to your account. Once you are inside, click on Website in the sidebar. This takes you to your website list where all your projects live. Click the Add New Website button. On the next modal, scroll down and select Node.js as your project type. This is important. Interview Ninja is a Next.js app, and it needs a Node runtime, not a static site host. Select it and continue. You will be asked to connect your GitHub account if you have not already. Connect it, then select the Interview Ninja repository from the list. Choose your main branch as the deployment source. Now before you hit deploy, go to the environment variable section. This is where you add your 4 variables. Next, public InsForge URL set to your InsForge project URL. Next, public InsForge anon key set to your anon JWT from the InsForge dashboard. Anthropic API key set to your Claude API key. And next, public app URL set to your production domain. Once all 4 are saved, click deploy. Hostinger pulls your code from GitHub, installs the dependencies, runs the Next.js build, and starts the server. You can watch the build logs in real time right there in the dashboard. When you see the build complete message, your app is live. Go to your assigned domain or custom domain, open it in the browser, and you should see Interview Ninja running exactly as it does on localhost. If you want to try it yourself, link is in the description. Use my coupon code ALBERTAI at checkout to get a discount on your plan. It is my personal code, so it helps the channel too when you use it. Alright, let us actually build the thing. Today we are building Interview Ninja from scratch. This is a full stack AI-powered interview platform with 2 sides, a candidate dashboard and a recruiter dashboard. Authentication is handled by InsForge. The UI shell is already set up, and by the end of this video, we will have the entire thing built, connected, and running live. But first, we need to get the starter project on our machine. Let us do that right now. Open a fresh terminal. Make sure you can see the current directory. We are going to clone the starter repository, so everything begins from the same point. Run this command: git clone https github.com -albert Interview Ninja Starter. Get Interview Ninja. Let that output print on screen. Do not rush past it. You want to see the clone complete before moving on. Before we install anything, let us see what we are working with. Run ls. You should see the following: src public package.json, next.config.ts, tsconfig.json, .env.example, and readme.md. This confirms the starter cloned correctly and everything is in place. Now open the project in your editor. If you are using VS Code, run code. Or open it from your editor's file picker if you prefer. Either way, get the project open so we can take a look at what is inside before we start the server. Take a quick look at the folder structure in the Explorer panel on the left. Inside SRC, you will see app, components, lib, and types. This is a standard Next.js app router project. The auth flow is already wired up. The UI shell is already built. Our job today is everything that goes on top of it. Let us quickly open a few key files so you understand the starting point. Open src/app/layout.tsx. This is the root layout. It loads the Sign and JetBrains monofonts from Google and wraps the entire app. Nothing to change here. Open src/app/page.tsx. This is the landing page. It has a hero section with 3 buttons: Preview Candidate, Preview Recruiter, and Sign In. This is just a shell. The real work happens inside the dashboard routes. Open src/app/candidate/dashboard/page.tsx. This is the candidate dashboard. Right now, it is running on mock data. You can see mock_sessions and mock_attempts defined at the top. The component renders interview summaries and recent submission stats. By the end of today, this will all be live data. Open src/app/recruiter/dashboard/page.tsx. Same thing on the recruiter side. Mock data for sessions and a live activity feed. The recruiter dashboard preview component renders KPIs, active coding sessions, and candidate activity. All of this will be real by the time we are done. Now open src/components/starter/starter authguard.tsx. This is the higher order component that protects routes. It uses InsForge.auth.getCurrentUser inside a use effect. If no user session is found, it clears the local auth hint and redirects back to the login page. This is already working. We do not need to touch it. Open src/lib/insforge.ts. This initializes the InsForge SDK client. It imports createClient from @insforge/sdk and exports an instance called InsForge, initialized with a base URL and an anonymous key pulled from environment variables. And finally, open src/types/sessionuser.ts. This defines the session user interface with 4 fields: ID, email, full_name, and avatar_URL. This is the shape of the user object we will be working with throughout the build. Now let us get the environment set up. In the terminal, run cp.env.example, env.local. This copies the example environment file into the local version that Next.js will actually read. Open .env.local in the editor. You will see 3 variables: next_public_insforge_URL, which is your InsForge project URL, next_public_insforge_anon_key, which is your anonymous JWT key, and next_public_app_URL, which should be set to http://localhost:3000 for local development. Fill in your InsForge URL and anon key from your InsForge project dashboard. Run the dev server. npm run dev. Next.js starts up and you should see it listening on http://localhost:3000. Switch to the browser and navigate to localhost 3000. The Interview Ninja landing page loads. Click Preview Candidate. The browser takes you to /candidate/dashboard, and you can see the Hey Alex dashboard with the mock interview data. Click Recruiter in the top nav. You land on the Hey Morgan Recruiter view with the KPI cards and the activity feed. Now click Sign in the top right. The login page loads with the Continue with Google button. If your InsForge credentials are correctly set in .env.local, clicking that button will initiate the Google OAuth flow. If you see a network error here, it means the environment variables are not set correctly yet. In the next step, we start building out the real data layer and connecting everything to a live backend. Let us keep going. Before we start building, let me quickly show you the platform powering the backend of this entire project. Open a new tab in the browser and navigate to insforge.dev. This is InsForge. The headline says it all. The backend built for agentic development. You can see the CLI command right there on the landing page. But what I want you to notice is what InsForge actually gives you out of the box. Scroll down and you can see the full feature list. Postgres database for structured data, cloud storage for files and images, authentication with OAuth and link-based logins, serverless functions, real-time data sync, AI integration for connecting language models, and deployment. That is a complete backend stack. No stitching together 5 different services. It is all in one place. Keep scrolling and there is a performance comparison section. InsForge benchmarks at 1.6 times faster, 30% fewer tokens, and 1.7 times higher accuracy compared to alternatives. And at the bottom of the page, you can see the scale it is running at. Over 18,000 total projects and over 173,000 megabytes of database size. This is what we are building on today. Now let us look at how it works. Switch to VS Code. The project is already open. Let us orient ourselves before we start writing any code. Open .env.local. You can see 2 key variables already set. Next_public_insforge_URL is pointing to your InsForge app engine URL. Next_public_insforge_anon_key is your anonymous JWT key. These 2 values are what the SDK uses to connect to your backend. Make sure both are filled in with your actual project values from the InsForge dashboard. Now open src/app/auth/login/page.tsx. This is the login page. Hover over the use effect block and you can see the TypeScript signature for get current user. It returns a promise that resolves to either a user schema or an InsForge error. The auth flow is already wired. We do not need to rebuild it. We just need to make sure the SDK client is initialized correctly and pointing at the right project. Before we write that initialization, let us spend a minute in the documentation so you understand exactly what we are doing. Go back to the browser and navigate to docs.insforge.dev. Land on the introduction page, then go to core concepts, then authentication architecture. Read through this section. The technology stack uses JWT with HS256, HMAC-SHA256, and stateless JWT tokens. The authentication flow covers email verification and link-based logins. There is also session recovery built in, and the JWT token structure is documented, so you know exactly what fields are available on the decoded token. Scroll down to SDK references, and you can see InsForge supports TypeScript, Swift, Kotlin, and Flutter. We are on TypeScript today. Now navigate to core concepts, then database architecture. This is worth knowing. InsForge uses PostgreSQL 15 with Postgres 12. The way it works is you define your schema. Postgres auto generates the API layer. and queries are translated transparently. The data types table shows you how InsForge types map to PostgreSQL types and JSON types. Text, integer, float, boolean all behave exactly as you would expect. Navigate to core concepts, then storage architecture. InsForge uses an S3 compatible storage system. The upload flow, download flow, and security features including bucket policies and JWT authentication are all documented here. We will come back to storage when we build the file upload feature. Now navigate to getting started, then quick start. 2 steps: create your project and install the InsForge CLI. Then navigate to TypeScript, then TypeScript SDK. Find the installation command under the installation header. Highlight it and copy it. npm install at insforge/sdk at latest. Switch back to the VS Code terminal. Paste the command and run it. npm install at insforge/sdk at latest. The output confirms it's installed correctly. 1 package added, 377 packages audited. Now go back to the browser documentation one more time and find the quick start code block. It shows exactly how to initialize the client. Import create client from at insforge/sdk const insforge equals create client with base URL set to your app URL and anon key set to your anonymous key. That is the pattern. Now let us implement it properly using environment variables. Open src/lib/insforge.ts. This is where the SDK client lives. Write the following: import create client from at insforge/sdk. Then pull the 2 values from environment variables, const base URL equals process.env.next _public _insforge _URL with a fallback to an empty string. Const anon key equals process.env.next _public _insforge _anon _key with a fallback to an empty string. Then export the client. Export const insforge equals create client with base URL and anon key passed in. That is the entire file. 5 lines. But this single export is what every other file in this project imports when it needs to talk to the backend. The database, authentication, storage, and real-time features all flow through this one client instance. Save the file. The SDK is initialized. The client is pointing at your InsForge project. We are ready to start building. Alright, the SDK is installed and the client file is ready. Now we need to create the actual InsForge project on the dashboard and connect it to our local codebase. Let us do that now. Go back to the browser. We are on the InsForge documentation page. Navigate to insforge.dev. In the top right corner, hover over the profile icon next to the dashboard button and click dashboard from the drop-down. The organizations page loads. You can see one existing organization called Personal Org on the free tier with one project already inside it. Click that organization card. Inside the organization, you will see the existing project. We do not want to use that one. Click the plus new project button on the right side of the screen. A create project modal appears over a map background. Type Interview Ninja into the project name field. The region defaults to US East, North Virginia. Leave that as is and click Create Project. A loading screen appears with the InsForge logo and the message, Building Project. This may take 2 to 3 minutes. Let it run. Do not close the tab. When the project dashboard finishes loading, a Connect Project modal automatically pops up. This is exactly what we need. Step 1 is Link Project. It gives you a terminal command that looks like this: npx at insforge/clilink --project-id followed by your project ID. Copy that command. We are going to run it in VS Code right now. Switch to VS Code. The insforge.ts file is open in the editor. You can see the client initialization we wrote earlier. Open the integrated terminal at the bottom and paste the command you just copied. Hit enter. The terminal asks, need to install the following packages at InsForge/CLI. OK to proceed. Type Y and press enter. The CLI package downloads and installs. You will see a few npm warning messages about unsupported engines for PostgreSQL node. Ignore those. They do not affect functionality. Watch the terminal output. It runs through several steps. Installing InsForge agent skills. InsForge agent skills installed. Installing find skills installed. And then linked to Project Interview Ninja. Switch back to the browser. In the top center of the screen, you should see a green toast notification. Successfully established connection with the agent. And in the dashboard getting started area, the agent status has changed from not connected to a green connected. You can see a visualization showing the agent box connected to the database box with one MCP call. The link is live. Now click the connect button in the top right corner of the dashboard to reopen the connect project modal. This time we want step 2, verify connection. Copy the prompt text from that step. It reads, I am using InsForge as my backend platform. Read the current directory, make sure InsForge skills are installed, and use InsForge CLI for backend tasks. Switch back to VS Code and open the Composer or Chat interface in your editor. Paste that prompt and send it. The AI agent starts processing. It reads the CLI skill and project configuration, explores the project structure, identifies the components, lib and src directories, and reads package.json to confirm the InsForge SDK is listed as a dependency. Then it checks .env.local and notices the placeholder values for next_public_InsForge_URL and next_public_InsForge_anon_key. These need to be real values before the app can talk to the backend. The agent runs the InsForge CLI skill to fetch the full backend metadata for the linked project. It retrieves the actual anon key from the project secrets automatically. Then it applies the fix directly to .env.local. You can see the diff in the editor. Next_public_InsForge_URL is updated from the placeholder to your real InsForge App Engine URL. Next_public_InsForge_anon_key is updated from the placeholder to the full JWT string. The agent then summarizes what it did, verified the project link, retrieved the URL and anon key, and updated the environment variables. You do not have to do any of that manually. The CLI and the agent handle it. Review the updated .env.local file to confirm both values are now populated correctly. The client is connected to a live backend. Before we move on, let us take a quick look around the InsForge dashboard so you know what is available. Go back to the browser and close the Connect project modal. In the left sidebar, click Authentication. The users list is empty for now. That makes sense. Nobody has signed in yet. Click Auth methods under Authentication. You can see 3 providers configured: email password, Google OAuth, and GitHub OAuth. Click the 3-dot menu next to Google OAuth and select Edit. The modal shows that shared keys are enabled for development. That is fine for now. Close the modal. Click Database in the sidebar. No tables yet. You can see template options like CRM, AI chatbot, e-commerce, Reddit clone, Instagram clone, and more. We are not using a template. We will build our own schema from scratch. Click SQL Editor. A query tab opens with a sample select statement. No results because there are no tables yet. We will come back here once we start defining our schema. Click Storage. The buckets list is empty. We will create a bucket later when we build the file upload feature. Click the settings gear icon at the very bottom of the sidebar. Project settings shows your project name as Interview Ninja, the project URL, the masked API key, and the version. Everything looks correct. The InsForge project is created. The local code base is linked. The environment variables are populated with real values. The AI agent is connected and verified. We are fully set up. In the next step, we start building the database schema and wiring up the real data layer. Let us keep going. Alright, the project is linked, the environment variables are set, and the dev server is running. Now we need to build the database schema. This is the foundation everything else sits on. Get this right and the rest of the build moves fast. Let us open the schema.sql file. The first thing at the top is the UID extension. This enables UUID generation inside PostgreSQL, so every row gets a unique identifier automatically. Run that first before anything else. Below that, we define two enums. The first is user_role with two values, candidate and recruiter. Every user in this system has one of these two roles, and that determines what they can see and do inside the app. The second enum is difficulty with three values, easy, medium, and hard. This is used on the questions table. Now the tables. The users table is the foundation. It has 6 fields. ID is a UUID that defaults to UUID_generate_v4. Email is a unique text field. Full underscore name is text. Avatar underscore URL is text. Role uses the user underscore role enum we just defined and defaults to candidate. And created underscore at is a timestamp that defaults to now. Every person who signs in through Google OAuth gets a row in this table. The row field is what splits the app into two experiences, the candidate dashboard and the recruiter dashboard. The interview underscore sessions table is what recruiters create when they set up a new interview. It has an ID, a recruiter underscore ID that references the user's table, a title, a description, an active boolean that defaults to true, and a created underscore at timestamp. The questions table belongs to a session. Each question has an ID, a session underscore ID that references interview underscore sessions, a prompt field for the actual question text, a difficulty using our enum, an expected underscore concepts field for what a good answer should cover, and an order underscore index so questions display in the right sequence. The candidate underscore attempts table is the most important one for tracking performance. It records every time a candidate submits an answer to a question. It has a candidate underscore ID referencing users, a question underscore ID referencing questions, a code underscore submitted field for the actual code they wrote, a language field for the programming language, a score field, and a feedback field for AI generated evaluation notes. Now the row level security policies. This is the part that makes the app actually secure. For the users table, a user can only read and update their own row. You cannot fetch another user's profile. For interview underscore sessions, recruiters can only see sessions they created. They cannot see sessions belonging to other recruiters. For questions, access is tied to the session. If you have access to the session, you can see the questions inside it. Candidates can see questions in sessions they are participating in. For candidate underscore attempts, a candidate can only see their own attempts. A recruiter can see attempts submitted by candidates in their sessions. Nobody can see data that does not belong to them. This is not optional. Without these policies, any authenticated user could query any table and see all data. With them, the database enforces access control at the row level regardless of what the API receives. Now let us run this against the live database. Switch to the browser and open the InsForge dashboard for the Interview Ninja project. Navigate to the SQL Editor tab in the left sidebar. Paste the entire contents of schema.sql into the query editor. The script is around 156 lines. Make sure the full content is in there before you run it. Click the Run button. Watch the results pane. If everything goes correctly, you will see confirmation that each statement executed successfully. The tables will be created, the RLS policies will be applied, and the trigger function will be registered. If you hit an error that reads column ID of relation buckets does not exist, this is coming from line 137 in the schema. That line tries to insert directly into storage.buckets to create a code submissions bucket for file uploads. The issue is that the InsForge storage schema handles bucket creation differently than a direct SQL insert expects. Do not try to force this through the SQL editor. Instead, remove that storage insert line from your schema script entirely. Paste the cleaned version back into the SQL editor and run it again. Once the rest of the schema is created successfully, go to the storage section in the InsForge dashboard sidebar and create the code submissions bucket manually through the UI. Set it to private. That achieves exactly the same result without the schema conflict. Once the schema runs without errors, go to the database section in the InsForge sidebar. You should see all 4 tables listed: users, interview underscore sessions, questions, and candidate underscore attempts. Click on each one to confirm the columns are correct. The database is built, the schema is live, row level security is enforced. The trigger is ready. In the next step, we start connecting the front end to this data and building out the real candidate and recruiter experiences. Let us keep going. Now let us install the remaining dependencies. Open the integrated terminal and run npm install at Monaco editor /react at Anthropic AI /SDK date fns. Monaco editor is the code editor component we will embed in the candidate interview view. The Anthropic SDK is what powers the AI feedback engine that evaluates candidate answers, and datefns handles all the date formatting throughout the app. The installation will finish in a few seconds. You may see a note about moderate severity vulnerabilities. Acknowledge it and move on. It does not affect what we are building today. Now the TypeScript types. This is important. Get this right and every component in the app benefits from full type safety all the way down to the database row level. In the File Explorer, navigate to src/types. Create a new file called database.ts. Open the file. We are going to build this out section by section. Start with the enums. These mirror exactly what we defined in the SQL schema. Export type user role equals candidate or recruiter. Export type difficulty equals easy, medium, or hard. Now the feedback results interface. This is the shape of the AI-generated evaluation that gets stored in the feedback field on candidate attempts. Define it like this. Export interface feedback results with the following fields. Score is a number. Strengths is a string array. Weaknesses is a string array. Improvements is a string array. Summary is a string. Time underscore complexity is a string. Space underscore complexity is a string. This shape is what Anthropic returns after evaluating a candidate's code submission. Every field matters. Score drives the numeric display. Strengths, weaknesses, and improvements populate the feedback breakdown. Summary is the overall assessment, and the complexity fields give technical depth to the evaluation. Now the main database interface. This is the full typed representation of the database schema. Structure it like this. Export interface database with a public key containing a tables key. Inside tables, we define each table with row, insert, and update subtypes. For the users table, the row type has ID as string, email as string, full underscore name as string or null, avatar underscore URL as string or null, role as user role, and created underscore at as string. For interview underscore sessions, the row type has ID as string, recruiter underscore ID as string, title as string, description as string or null, is underscore active as boolean, and created underscore at as string. For questions, the row type has ID as string, session underscore ID as string, prompt as string, difficulty as difficulty, expected underscore concepts as a string array, and order underscore index as number. For candidate underscore attempts, the row type has ID as string, candidate underscore ID as string, question underscore ID as string, code underscore submitted as string or null, language as string or null, score as number or null, feedback typed as feedback result or null, and created underscore at as string. Finally, add the helper type aliases at the bottom of the file. These give us clean import names everywhere in the app instead of repeating the long database bracket path each time. Export type user equals database public tables users row. Export type interview session equals database public tables interview underscore sessions row. Export type question equals database public tables questions row. Export type candidate attempt equals database public tables candidate underscore attempts row. Save the file. All TypeScript errors should resolve immediately. These 4 type aliases are what every component, hook, and API function in this app will import. When you fetch a user from the database, it comes back typed as user. When you create a session, the insert shape is enforced by the database interface. When Anthropic returns feedback, it gets stored as feedback result inside the candidate attempt row. The schema is live, the dependencies are installed, the types are defined, everything is in place. In the next step, we start building the actual candidate and recruiter experiences on top of this foundation. Let us keep going. Alright, the types are defined. Now we need a proper authentication guard component that does more than just check if a user is logged in. It also needs to verify that the user has the correct role before letting them into a protected route. A candidate should not be able to access the recruiter dashboard and vice versa. Let us build that now. Start by opening src/types/database.ts to remind yourself of the types we just defined. You can see user role as a union of candidate and recruiter. You can see difficulty as easy, medium, or hard. And you can see the full database interface with the user's table row type containing ID, email, full underscore name, avatar underscore URL, role, and created underscore at. We are going to use these throughout what we build next. In the File Explorer, expand src/components/starter. Open starter authguard.tsx. This is the existing AuthGuard from the starter kit. It handles 3 states: loading, unauth, and ready. We are going to use this as a template and build a proper version on top of it. Right-click on the src/components folder and create a new folder called auth. Inside that folder, create a new file called authguard.tsx. Select the entire contents of starter authguard.tsx. Copy everything and paste it into the new authguard.tsx file. This gives us the starting structure. Now update the props. The function signature currently just takes children. Add a second parameter, required role typed as candidate or recruiter. This is what callers will pass in to tell the guard which role is allowed on this particular route. Add an import for the user type from @types/database at the top of the file. Now update the internal state type. The current version is a simple string union. We need a discriminated union that carries data in the ready state. Define state as a union of 3 shapes. The first has status as the string loading. The second has status as the string unauth. The third has status as the string ready and includes a profile field typed as user. We also add a fourth shape with status as the string setup for users who have authenticated but not yet completed their profile. Now modify the run function inside the use effect. First call await InsForge.auth.getCurrentUser. Check the result. If there is an error or the data.user is missing, trigger the logout flow. Call clear auth hint, set state to unauth, and call router.replace with /auth/login. Return early. If a user exists, extract the user ID. Const ID as user ID equals data.user. Now fetch the user profile from the database using the InsForge client. Const data as profile equals await InsForge.database.from-users.select*.eqid, user ID dot may be single. Handle the case where no profile exists yet. If profile is falsy, call setState with status set to setup and return early. This sends users who authenticated but never completed onboarding to a setup flow. Now the role check. If profile.role does not equal the required role prop, redirect the user to their correct dashboard. If they are a recruiter trying to access a candidate route, redirect to /recruiter/dashboard. If they are a candidate trying to access a recruiter route, redirect to /candidate/dashboard. This enforces role-based access control at the component level. If the user is authenticated, has a profile, and the role matches, update the state to ready. Set state with status set to the string ready and profile set to profile cast as user. Now update the JSX render block. Check state.status. If it equals loading, render a full screen div with a spinner and the text restoring session. Keep this minimal. Users should see it for less than a second in most cases. If status equals unauth or setup, return null. The redirects inside use effect are already handling navigation, so there is nothing to render. If status equals ready, render the application layout. Pass the profile from state to the sidebar component. Start a sidebar with user set to state.profile. The component is now fully type safe. Save the file. Let us quickly review what this component does end to end. When a protected page mounts, AuthGuard shows a loading state while it checks the session. If no session exists, it redirects to login. If a session exists but no profile, it redirects to setup. If a profile exists but the role is wrong, it redirects to the correct dashboard. Only when all three checks pass does it render the actual page content with the user profile available to every child component. Every protected route in this app will wrap its content in this component with the appropriate required role prop. That is one component handling authentication, profile existence, and role-based access control in a single clean package. In the next step, we start building the recruiter and candidate dashboard experiences on top of this guard. Let us keep going. Alright, the AuthGuard is done. Now we need a sidebar that knows who is logged in and renders the correct navigation for their role. A candidate sees candidate routes, a recruiter sees recruiter routes, and we are going to add a role switcher button for development, so we can toggle between the two views without creating separate accounts. Let us build it. Start by opening src/component/starter/starter sidebar.tsx. This is the template sidebar from the starter kit. It has a static nav array with just two items, dashboard and settings. We are going to use this as a base and build something much more capable on top of it. In the File Explorer, navigate to src/components/UI. Right-click and create a new file called sidebar.tsx. sidebar.tsx. Go back to starter sidebar.tsx. Select the entire file content, copy everything, and paste it into the new sidebar.tsx. Now we refactor. First, rename the component function from starter sidebar to sidebar everywhere in the file. Now define two interfaces at the top of the file. The first is nav item. It has three fields: href as string, label as string, and icon as react.element type. Use element type, not React node here. Element type allows us to pass lucid icon components as values and render them dynamically inside the map function. Now build the candidate navigation array. Const candidate nav typed as navitem array. It has 4 items. The first item has href set to /candidate/dashboard, label set to dashboard, and icon set to layout dashboard. The second has href set to /candidate/sessions, label set to sessions, and icon set to folder open. The fourth has href set to /candidate/history, label set to history, and icon set to history. Now build the recruiter navigation array. Const recruiter nav typed as navitem array. It has 3 items. The first has href set to /recruiter/dashboard, label set to dashboard, and icon set to layout dashboard. The second has href set to /recruiter/sessions, label set to sessions, and icon set to folder open. The third has href set to /recruiter/candidates, label set to candidates, and icon set to user icon. Now write the switch role helper function inside the component. Async function switch role. First determine the new role, then update the database. Await insforge.database.fromUsers.update with role set to new role.eqid user.id. Then navigate, call router.refresh to update server components, then router.push to the appropriate dashboard based on new role. If new role equals candidate, push to /candidate/dashboard. Otherwise, push to /recruiter/dashboard. This function is primarily for development. It lets you test both sides of the app without maintaining 2 separate accounts. In production, you would remove it or gate it behind an admin check, so the wiring is already in place. In the next step, we start building the actual recruiter and candidate dashboard pages. Let us keep going. Alright, the AuthGuard component is built and the sidebar is role aware. Now we need to actually wire them into the routing system. In Next.js app router, the way you protect an entire section of your app is through layout files. We are going to create one layout for the candidate portal and one for the recruiter portal. Each layout wraps its route in the AuthGuard with the correct required role. 2 files, about 8 lines each, and every route in those directories is protected. Let us do it. In the File Explorer, navigate to src/app/candidate. Right-click the candidate folder and create a new file called layout.tsx. Open the empty file and write the following from scratch. Import AuthGuard from @/components/auth/authguard. Then export the default function. Name it candidate layout. It takes 1 prop, children typed as react.reactNode. In the return block, wrap children inside the AuthGuard component. Set the required role prop to the string candidate. That is the entire file. 5 lines of actual code. But what those 5 lines do is significant. Every single page inside the candidate folder, every route, every subroute now requires the user to be authenticated and have the candidate role before it renders. If they are not logged in, AuthGuard sends them to the login page. If they are logged in but have the recruiter role, AuthGuard sends them to the recruiter dashboard. Only verified candidates get through. Now the recruiter layout. Navigate to src/app/recruiter. Right-click the recruiter folder, and create a new file called layout.tsx. Open it. Highlight the entire content of the candidate layout file, copy it and paste it here. Make 2 changes. Rename the function from candidate layout to recruiter layout. Change the required role prop from the string candidate to the string recruiter. Save the file. That is it. The recruiter portal now has the same protection layer as the candidate portal. Unauthenticated users get redirected to login. Authenticated users with the wrong role get redirected to their own dashboard. Only verified recruiters see recruiter roles. Now let us test that this actually works. Switch to the browser and navigate to localhost 3000. The landing page loads normally. Now type localhost 3000/candidate/dashboard directly into the address bar and hit enter. Watch what happens. The screen briefly shows restoring session ... That is the AuthGuard loading state running its checks. Because we are not logged in, there is no valid session. The AuthGuard catches this, clears the auth hint, and redirects. The browser lands on localhost 3000/auth/login. The sign-in page appears with the continue with Google button. The guard is working correctly. Direct URL access to protected routes is blocked. The routing protection is live. 2 layout files, 8 lines of code combined, and the entire candidate and recruiter sections of the app are now behind authentication and role verification. Every new page you add under either folder inherits this protection automatically. You never have to think about it again. In the next step, we start building the actual dashboard content for both roles. Let us keep going. Alright, the routing protection is in place. Now we start replacing mock data with real data. The candidate dashboard currently shows hard-coded sessions and attempts. By the end of this step, it will be pulling live data from the InsForge database for the actual logged-in user. Let us do that now. Open src/app/candidate/dashboard/page.tsx. The first thing you will notice is mock_sessions and mock_attempts defined as constants near the top of the file. Hover over them. These are static arrays. Nothing about them is connected to a real user or a real database. We are replacing all of this. At the very top of the file, on line 1, type use client. This converts the component from a server component to a client component. We need this because we are going to use useEffect and useState for client-side data fetching. Without the useClient directive, React hooks are not available. Now add the React imports. On a new line near the top, add import useEffect. useState from React. The editor should autocomplete this. Accept the suggestion. Now write the useEffect hook directly after the state declarations. useEffect with an empty dependency array, so it only runs on mount. Now fetch the profile and the data we need. First the profile. Const data as profile equals await InsForge .database.from users .select star .eqid user id .maybe single. Then use promise.all to fetch sessions and attempts at the same time, so we are not waiting for them sequentially. Const sessions data and attempts data equals await promise.all with 2 queries inside. The first query, insforge.database.from interview_sessions.select star .eq is _active true.order created _at with ascending false.limit 5. The second query, insforge.database.from candidate_attempts.select star and interview_sessions title.eq candidate_id user id.order submitted _at with ascending false.limit 5. Notice the second query uses a join to pull the session title alongside each attempt. This is what lets us display the session name next to each submission in the history list. After both queries resolve, check the cancelled flag before setting any state. If cancelled, return. Update the AVG score calculation. To use the dynamic attempts state, const AVG score equals attempts dot length greater than 0. Question mark attempts dot reduce summing. Each attempt dot score divided by attempts dot length dot to fixed 1 colon null. Now update the JSX. This is where the dashboard visually connects to real data. The greeting line, change it to hey, then profile dot full underscore name dot split space bracket 0 with a fallback to the string there, followed by an exclamation mark. This shows the user's first name if available. The sessions KPI card, replace the hard-coded number with total sessions. The submissions KPI card, replace it with attempts.length. The average score KPI card, replace it with AVG score with a fallback display for when no attempts exist yet. The sessions list, replace the map over mock underscore sessions with a map over the sessions array. Use session.id as the key. The attempts history list, replace the map over mock underscore attempts with a map over attempts. Use attempt.id as the key. For the session title, use attempt.interview underscore sessions dot title if the join data is available. Once the session issue is resolved and a user is fully authenticated with the candidate role, the dashboard will load the real profile name, the real session count, the real submission history, and the real average score from the database. In the next step, we fix the authentication callback flow and get a clean end-to-end login working. Let us keep going. Alright, the candidate dashboard is pulling live data. Now we need to build the most important back-end feature in the entire app, the AI code evaluation endpoint. This is what runs when a candidate submits their code during an interview. It sends the code to Claude, gets back a structured evaluation with a score, strengths, weaknesses, and complexity analysis, saves it to the database, and returns it to the UI. Let us build it. In the File Explorer, right-click the src/app directory and create a new folder called API. Inside API, create another folder called Evaluate. Inside Evaluate, create a new file called root.ts. Open the empty file. We are building a post handler here. Start with the imports at the top of the file. Import next response and next request from next/server. Import Anthropic from @Anthropic AI/SDK. Import create client from @InsForge/SDK. Import the feedback result type from @/types/database. Now set up the InsForge client configuration. Pull the base URL and a non-key from environment variables. Const InsForge base URL equals process.env.next_public_InsForge_URL with a fallback to an empty string. Const InsForge anon key equals process.env.next_public_InsForge_anon_key with a fallback to an empty string. Define a helper function called createInsForge_client that takes an access token as a string and returns a Prisma client instance initialized with the base URL, anon key, and access token. This is how we make authenticated database calls from the API route using the user's own token. Now define the evaluate request interface. This describes the shape of the request body, question ID as string, session ID as string, candidate ID as string, code as string, language as string, prompt as string, expected concepts as an optional string array. Now two utility functions. The first is sleep. It takes milliseconds as a number and returns a promise that resolves after that timeout. We use this for retry backoff. The second is retriable error. It takes an unknown error and returns a boolean. It checks if the error is a 429 rate limit or a 529 overloaded response from Anthropic, or if the error message contains the strings overloaded or rate underscore limit. This tells us whether it is worth retrying or whether we should fail fast. Now the fallback feedback function. Name it build fallback feedback. It takes code and expected concepts as parameters and returns a feedback result. This runs when Claude is unavailable after all retries are exhausted. It calculates a basic heuristic score starting at 8. It checks the line count of the submitted code. If the code has more than 6 lines, it adds a point for completeness. It checks whether the code contains keywords from the expected concepts array and adjusts the score accordingly. It returns a feedback result with hard-coded strings in the summary field explaining that the AI evaluation is temporarily unavailable, and basic strengths and improvements derived from the line count and keyword matches. This is not a replacement for real AI evaluation. It is a safety net that ensures the candidate always gets some form of feedback even when the API is having issues. Now the Claude wrapper function. Name it call Claude with retry. It takes 3 parameters: an Anthropic client instance, an evaluation prompt string, and a max attempt number defaulting to 4. Inside, use a for loop that runs up to max attempts times. On each attempt, call anthropic.messages.create with the model set to Claude 3 Opus 2002-4229, max token set to 1000, and the evaluation prompt as the user message content. If the call succeeds, extract the text from the response, pass it as JSON, and return it cast as feedback result. If the call fails, check its retryable error. If it is retryable, calculate an exponential back-off delay using math.pow of 2 and the attempt index, multiply by 1000 milliseconds, and await the sleep function with that delay. Then continue to the next attempt. If the error is not retryable, throw immediately. No point waiting for more retries on a permanent failure. Now the main post handler. Pass the request body and extract all the fields from the evaluate request shape. Validate that question ID, session ID, and candidate ID are all present. If any are missing, return a 400 bad request with a clear error message. Check that Anthropic API key exists in the environment variables. If not, we will still run but using the fallback. Extract the bearer token from the authorization header. This is the user's InsForge access token used to make authenticated database calls on their behalf. Build the evaluation prompt. This is the instruction set you send to Claude. Tell Claude it is acting as a senior technical interviewer. Give it the question prompt, the candidate's code, the programming language, and the list of expected concepts. Provide a scoring rubric from 0 to 10. 0 to 3 for non-functional or completely off-topic code. 4 to 6 for functional code with issues. 7 to 8 for solid implementations. 9 to 10 for exceptional work. Instruct Claude to return only a JSON object with no extra text. The schema must include score as a number, summary as a string, strengths as a string array, improvements as a string array, weaknesses as a string array, time underscore complexity as a string, and space underscore complexity as a string. Strict JSON output is critical here. The call Claude with retry function passes the response directly. Any markdown, explanation, or extra text outside the JSON will break the pass. Now call Claude with retry inside the try catch block. If it succeeds, store the result in a feedback variable and set used fallback to false. If it throws, log a warning, set used fallback to true, and call build fallback feedback with the submitted code and expected concepts. Now persist the result to the database. Create an InsForge client using the user's access token. construct a storage path for the raw code file, something like candidate/candidate ID/question, id.ts or .pi depending on the language. Upload the code as a text file to InsForge storage. Check whether an attempt already exists for this candidate ID and question ID combination using a select query with maybe single. If a row exists, call .update with the new score, feedback, code, language, and storage path. If no row exists, call .insert with all the same fields plus the candidate ID and question ID. If the database operation fails, return a 500 error, but still include the feedback object in the response body. The UI can display the evaluation even if the database write failed. The candidate should not be left with nothing just because a database call had a transient issue. If everything succeeds, return a 200 response with the feedback, the score, and a used fallback flag so the UI can optionally show a notice when the fallback kicked in. Every piece has a clear responsibility. Save the file. Now quickly open src/app/auth/login/page.tsx. This is the login page. This is the entry point for all user authentication. We want to make sure the flow from Google OAuth through to the dashboard is clean before we test the full evaluation pipeline end to end. In the next step, we fix the auth callback flow and then test a complete candidate session from sign-in through code submission and AI evaluation. Now open .env.local. We need to add the Anthropic API key, navigate to a new line at the bottom of the file, and type Anthropic_API_key equals, leave the value empty for now. We are going to get the real key from the Anthropic console. Switch to the browser. Open a new tab and search for Claude API key. Click the link to platform.anthropic.com. The API keys page loads. Navigate to the API keys section in the left sidebar if it does not open directly. Then click the Create Key button. A modal appears asking you to name the key. Type Interview Ninja into the name field and click Create. The next modal shows your new API key starting with skent API03, followed by a long string. This key is only shown once. Click the Copy Key button immediately to copy it to your clipboard before closing this modal. Once you have it copied, close the modal. Switch back to VS Code, open .env.local. Find the Anthropic_API_key line you added. Highlight the empty value and paste the key you just copied. The final line should read Anthropic_API_key equals your full key, starting with skent API03. Save the file. One important note about the key you just created. The Anthropic console showed it to you once, and now it is gone. If you lose this value from your .env.local file, you will need to generate a new one. Never commit this file to Git. It should already be in your .git ignore from the starter project, but double check. The key gives full API access to your Anthropic account, and any requests made with it are billed to you. Also, restart your development server after adding the new environment variable. Next.js reads environment variables at startup. If the server is already running, it will not pick up the new Anthropic_API_key value until you restart. Stop the server with Ctrl+C in the terminal and run npm run dev again. With the key in place, the evaluate route can now call Claude. The flow is candidate submits code, the dashboard posts to /API/evaluate with the code and question context. The route builds the evaluation prompt, calls Claude with retry logic, gets back a scored JSON response, saves it to the candidate_attempts table via InsForge, and returns the feedback to the UI. If Claude is unavailable or rate limited, the fallback function we wrote kicks in and the candidate still gets a response. The UI can check the used fallback flag in the response to show a notice if needed. Everything is now in place to test a full end-to-end evaluation. In the next step, we build the actual interview session UI, where candidates see questions and submit their code. Let us keep going. Alright, the evaluation API is wired up and the Anthropic key is in place. Now we need to build the page where candidates actually browse and select interview sessions. This is the entry point into the interview experience. A candidate lands here, sees all the active sessions available to them, picks one, and enters the interview. Let us build it. In the File Explorer, navigate to src/app/candidate. Right-click the candidate folder and create a new folder called Session. Inside that folder, create a new file called page.tsx. Open the empty file. At the very top, type Use Client. This is a client component because we are using useEffect and useState for data fetching. Without this directive, the hooks will not work. Now add the imports. We need several things: useEffect and useState from React, link from Next/link, arrow right from Lucid React, format distance to now from datefns, and InsForge from art/lib/InsForge. Use the art/alias for all local imports rather than relative paths. This keeps the imports clean as the project grows. Define the component, export default function, sessions list page. Inside the function, declare 3 state variables. The first is loading. Const loading, set loading equals useState typed as boolean, initialized to true. The second is sessions. This one has an inline type for the array items. Const sessions, set sessions equals useState typed as an array of objects, each with ID as string, title as string, description as string, and created underscore art as string. Initialize it to an empty array. Now the useEffect hook. This runs once on mount and fetches all active sessions from the database. Declare a cancelled variable set to false at the top of the effect. This prevents state updates from running if the component unmounts before the fetch completes. Define an async function inside the effect and call it immediately. Inside the async function, first get the current user. Await InsForge.auth.getCurrentUser. We do not strictly need the user data for this query since sessions are visible to all authenticated candidates, but calling getCurrentUser first confirms the session is valid before hitting the database. Then query the sessions table. Const data equals await InsForge.database. From interview underscore sessions dot select star dot eq is underscore active true dot order created underscore at with ascending set to false. If a recruiter deactivates a session, it disappears from this list automatically. After the query, check the cancelled flag. If not cancelled, call set sessions with data cast to the sessions array type and call set loading with false. Return a cleanup function from the effect that sets cancelled to true. Now the render block. Return the JSX. Wrap everything in the preview shell component with title set to the string sessions. If loading is true, render a simple loading state. A paragraph with the text loading sessions ... is fine for now. Otherwise, render the sessions grid. Inside the div, map over the sessions array. For each session, render a card div. Give it the session.id as the React key. Inside each card, render an h2 with the session.title. If a description exists, render a paragraph with session.description. Add a line clamp class to keep the card's uniform height if descriptions vary in length. Render the creation timestamp using format distance to now from date fns. Pass new date of session dot created underscore at and set add suffix to true. This gives you human readable output like 2 days ago. The candidate should be able to scan the list quickly and find what they need. Save the file. This page is now accessible at /candidate/session and is protected by the candidate layout we created earlier. Only authenticated users with the candidate role can reach it. The data is live from the database. Every time a recruiter creates a new active session, it appears here automatically. In the next step, we build the individual session page where the candidate actually sees the questions and writes their code. That is where the Monaco editor comes in and where the AI evaluation pipeline gets triggered. Let us keep going. Alright, this is the biggest build of the entire project. We are creating the live interview experience, the page where a candidate sees questions, writes code in a Monaco editor, and submits for AI evaluation. There are several files involved here, so let us go through them in order. Start in the File Explorer, navigate to src/app/candidate/session. Right-click and create a new folder called /session ID bracket. This is a Next.js dynamic route. The session ID in brackets tells the router that this segment is a URL parameter. Inside the bracket session ID bracket folder, create a new file called page.tsx. Open it. This is the route entry point. It handles data fetching and passes everything down to the interview client component. Add use client at the top. Import use effect and use state from React. Import use params from next/navigation. Import InsForge from @lib/InsForge. Import the interview session, question, and candidate attempt types from @types/database. Import interview client from @components/candidate/interview client. This file does not exist yet. We will create it next. The import will show an error temporarily. Now, the main component, navigate to src/components/candidate and create interview client.tsx. Set up the Monaco editor with a dynamic import so it never runs on the server. Const Monaco editor equals dynamic with a function that imports at Monaco editor/React and an options object with SSR set to false. The loading fallback for the dynamic import should render a centered div with a loader to spinner and the animate spin class. Define two constants. The first is languages, an array of objects. Each object has a value string, a label string, and a numeric ID. Include JavaScript, TypeScript, Python, Java, C++, Go, and Rust. The second is starter_code, a record typed as string to string. Map each language value to a short boilerplate comment. For Python, use #write your solution here, followed by a new line. For JavaScript, use / write your solution here, and so on for each language. This is what appears in the editor when a candidate first opens a question or switches languages. Define the interview client props interface with 4 fields. Session typed as interview session, questions typed as a question array, existing attempts typed as a candidate attempt array, and user ID typed as string. Inside the interview client component, set up the state variables. Current question index is a number initialized to 0. Language is a string initialized to JavaScript. Code is a record typed as string to string, initialized to an empty object. This stores the code the candidate has written for each question ID separately. Submitting is a boolean, initialized to false. Feedback is a record typed as string to any, initialized to an empty object. This stores the AI evaluation results for each question after submission. Scores is a record typed as string to number, initialized to an empty object. Then define two derived values. Current question equals questions, bracket current question index bracket. All answered is a boolean that checks if every question in the questions array has a corresponding entry in the feedback object. Use questions.every with a callback that checks if feedback bracket question.id bracket exists. Now the event handlers. Handle code change is a use callback that takes a value and updates the code record for the current question. ID set code with a spread of the previous code and a new entry using current question.id as the key. Handle language change takes a new language string. It updates the language state. If no code exists yet for the current question in the new language, it also resets the code for that question to the starter _ code value for the new language. Handle submit is an async function. It runs when the candidate clicks submit. Set submitting to true inside a try block. Get the authenticated HTTP client from insforge.auth.getHTTP client. Call fetch with /API/evaluate method post the authorization header using the token from the HTTP client, content type as application/JSON, and a JSON body containing question ID as current, question ID, session ID as session, .id, candidate, ID as user ID, code as the current code for this question. Language, prompt as current question.prompt, and expected concepts as current question.expected_concepts. Pass the response JSON. Update feedback and scores state with the returned values. In the catch block, handle errors and set a submit error state. In the finally block, set submitting back to false. Now the JSX layout. The outer wrapper is a FlexCool H screen container with background color. Hex 0E0E0E. The header section sits at the top. It shows the session title on the left. On the right, it renders a progress indicator, map over the questions array, and render a small dot for each. If the dot index equals current question index, it is the active dot and gets the accent color. If that question has a score, it gets the success color. Otherwise, it is muted. The main area uses a flex layout split into two panels with flex 1 to fill the remaining height. Then render the question prompt text in a scrollable container. The right panel is the code editor. Render the Monaco editor component with the following props. Value set to the current code for this question, defaulting to starter_code for the selected language. Language set to the language state. Theme set to VS Dark. OnChange set to handle code change. Options set to an object with minimap enabled false, font size 13, word wrap on, and padding top and bottom set to 16. Disable the button while submitting. If all answered is true, show a completion banner above the footer with a trophy icon and a congratulations message. Save both files. The session root, the badge component, and the interview client are all done. The flow end to end. A candidate navigates to /candidate/session, sees the list of active sessions, clicks one, lands on /candidate/session /the session ID, sees the first question with a difficulty badge, writes the code in the Monaco editor, clicks submit. The evaluate API route calls Claude. The result comes back. The feedback panel populates with the score and analysis, and the progress dot for that question changes color to indicate completion. Alright, the interview client component is built. Now we need the page that sits above it, fetches all the data, handles the different loading states, and passes everything down as props. This is the dynamic route page at /candidate/session slash the session ID. Let us build it. Line 1, type use client. This is a client component because we are using hooks. Now add the imports. Use effect and use state from React. Use params from next/navigation. This gives us access to the URL parameter. Interview client from @components/candidate/interview client. InsForge from @lib/InsForge. And the three database types: interview session, question, and candidate attempt from @types/database. Define the component, export default function, interview session page. Inside, call use params and extract the session ID. Const params equals use params. Const session ID equals params. Dot session ID cast as string. Note the lowercase I in session ID. This must match the folder name, bracket session ID bracket exactly. Next.js lowercases dynamic segment names by default. Now define the state. This component has 4 distinct UI phases, and we model them as a discriminated union. Define state with useState, typed as a union of 4 object shapes. The first has status as the string loading. The second has status as the string not found. This covers the case where the session ID is invalid or the session has been deactivated. The third has status as the string empty. This covers the case where the session exists but has no questions assigned yet. The fourth has status as the string ready. This is the success state. It includes session typed as interview session, questions typed as a question array, attempts typed as a candidate attempt array, and user ID as a string. Initialize useState with an object where status is the string loading. Now the use effect. Inside the effect, declare a cancelled variable set to false. Define an async function and call it immediately. First, get the current user. Const data as auth data equals await InsForge.auth.get current user. If auth data.user is falsy, set state to not found and return early. Extract the user ID. Const user ID equals auth data.user.id. Now fetch the session. Query the interview underscore sessions table where ID equals session ID and is underscore active equals true. Use may be single. If the result is null or not found, set state to not found and return. Now fetch the questions for this session. Query the questions table where session underscore ID equals session ID ordered by order underscore index ascending. If the questions array is empty or has no items, set state to empty and return. Now fetch any existing attempts this candidate has made in this session. Query candidate underscore attempts where candidate underscore ID equals user ID and question underscore ID is in the list of question IDs from the previous query. Use the in filter, passing an array of question IDs extracted from the question's result. After all 3 queries resolve, check the cancelled flag. If cancelled is true, return without setting state. Otherwise, call setState with status as the string ready and pass session, questions, attempts, and user ID into the object. Return a cleanup function that sets cancelled to true. Now the render block, check state.status. If it equals loading, return a full height centered div. Inside it, render a div with these classes: w5, h5 border 2 border of hex 2, 2 border t of hex 6 f4 f4, e rounded full animate spin. This matches the spinner style we used on the sessions list page. If it equals not found, return the centered paragraph that reads session not found. Use muted text styling. If it equals empty, return a centered paragraph that reads this session has no questions yet. Same muted styling. For the ready state, which is the default after the above checks, render the interview client component. Pass the following props: session set to state.session, questions set to state.questions, existing attempts set to state.attempts, and user ID set to state.userID. Save the file. Let us review the complete flow one more time. A candidate navigates to /candidate/session/SAM-ID. The page mounts and immediately enters the loading state. The useEffect fires, gets the current user, fetches the session, fetches the questions, fetches any existing attempts, and if everything is found, it transitions to the ready state. The interview client renders with all the data it needs. The candidate sees the first question, writes their code, submits, and the evaluation runs. If the session does not exist or is inactive, the candidate sees a clean not found message. If the session has no questions yet, they see an informative empty state. No crashes, no blank screens, no confusing behavior. This page is the bridge between the routing layer and the interview experience. It handles all the data concerns, so the interview client can focus purely on the UI and the evaluation logic. Now the recruiter side, creating sessions, managing questions, and viewing candidate results. We are not building that part in this video. That is your assignment. Everything you need is already in place. The database schema has the tables. The InsForge client is initialized. The AuthGuard and Sidebar are already role aware. You have seen exactly how the candidate side was built. Apply the same patterns to the recruiter routes and you will have a complete platform. Drop your implementation in the comments. I want to see what you build. Alright, the build is done. Open a new tab in the browser and navigate to the InsForge dashboard for your Interview Ninja project. Go to the SQL editor. Open the seed.sql file from your project. It contains an insert into questions block covering multiple sessions. Paste it into the editor and click Run. When it succeeds, you should see SQL query executed successfully. Verify the data. Go to database, open the interview_sessions table. You should see 3 sessions: front-end engineering, data structures and algorithms, and back-end systems. All 3 share the same recruiter_ID and all 3 are active. Now test authentication. Open a new tab and navigate to localhost 3000. Click Get Started. The login page loads. Click Continue with Google. Select your account. The app redirects through /auth/callback. You will briefly see completing sign in, then restoring session. The AuthGuard is running its checks. Once the session is verified, it redirects to the appropriate dashboard based on your role. If you land on the recruiter dashboard, you can see 3 active sessions listed. The UI shows the correct session count. Now use the role switcher in the sidebar. Click Switch to Candidate. The URL changes to /candidate/dashboard. The greeting updates. The 3 sessions you seeded appear in the available interview section. Now enter an interview. Click on Front-End Engineering. The URL navigates to /candidate/session/the session ID. The left panel shows question 1 of 3. Implement a debounce function in JavaScript. The difficulty badge reads medium. The right panel is the Monaco editor with a boilerplate function. Let us write a solution. Rename the default function to debounce. Define a timeout variable in the outer scope. Inside the returned function, call clear timeout with timeout. Then set timeout to a new set timeout that calls fn after the delay. The implementation uses a closure correctly. The timeout variable persists between calls and clears on each new invocation, which is the core mechanic of debounce. Click Submit. The Submit button enters a loading state while the evaluation API runs. The request goes to /API/evaluate with the code, the question metadata, and the authorization token. The route calls Claude with the evaluation prompt and waits for the structured JSON response. After a few seconds, the feedback panel populates. Score, 6 out of 10. Strengths, correct use of closures, correct clearing of the timeout on repeated calls. Improvement areas, the solution does not forward arguments using .apply with this and arguments and does not preserve the this context. These are critical for a robust debounce implementation that can be used with any function signature. This is exactly the kind of specific, actionable feedback a technical interviewer would give, not a vague pass or fail, a real evaluation of what is correct and what is missing. Now verify the data persisted. Go back to /candidate/dashboard. The stats now show one submission and an average score. Click History. The list shows the front-end engineering submission with the score. Now go to the InsForge dashboard, open the database section, and check the candidate underscore attempts table. A new row is there with the candidate ID, the question ID, the score, the full feedback object as JSON, and the language. Now go to storage and open the code submissions bucket. You should see .javascript files. These are the raw code files uploaded as blobs during the evaluation. The file path follows the pattern we defined in the root. Candidate/the candidate ID/the question ID.javascript. The data is persisting end to end. Code goes in, Claude evaluates it, the score and feedback land in the database. The raw code is saved to storage, and the dashboard reflects the updates in real time. And that is Interview Ninja, fully built and deployed. We went from a blank terminal to a live AI-powered interview platform. Google OAuth through InsForge, a Monaco code editor in the browser, Claude evaluating submissions in real time, data persisting to PostgreSQL with row-level security, and the whole thing running live on Hostinger. If you built along with this video, drop your deployment link in the comments. I want to see what you shipped. The recruiter side is your assignment, session creation, question management, candidate results. Everything you need is already in the code base. Apply the same patterns and you will have a complete platform. If you found this useful, subscribe. More builds like this are coming and you do not want to miss them. Code is in the description. Hostinger link and the discount code ALBERTAI are down there too if you want to deploy your own version. See you in the next one.